What I wanted to move on to now is the general solution for Cobb Douglas utility functions. So above what we use is what we're going to call a Cobb Douglas utility function, which is really important to get a handle around because it's going to be the most common, if not the only kind of utility that we're going to use in this course. With Cobb Douglas utility, the optimal consumption bundles are always going to take a particular form, which means that you do not always need to derive the full steps above to solve for the optimal consumption bundles. So in general, if there's one thing that I want you to take away from this section, it's going to be this. And it's really important to either memorize this or more importantly, to understand the intuition behind it. And if you understand the intuition behind it, then it'll be really easy to derive in the future. So what we're going to do is we're going to suppose that a consumer has utility given by over x and y given by x to the alpha and y to the beta. So notice here that the marginal rate of substitution, which is just going to be given by the marginal utility of x over the marginal utility of y. If you just take the partial derivative of this with respect to alpha, you'll get alpha times x, alpha minus 1 times y to the beta. And then if you take the partial derivative of this to get the marginal utility of y, you'll get beta times x raised to the alpha, that stays the same, times y beta minus 1. And so if you cancel all this out, you can notice that beta minus 1 is just a minus beta plus 1, and so y remains on the top. You can do likewise for x, and so x is just going to remain. If the MRS is equal to alpha over beta times y over x, then this just needs to be equal to the ratio of prices. And so what we should have is that px is going to be over py, and then this is going to allow us to solve for optimal x and optimal y, in addition to our budget constraints. So we need to also keep in mind that we're also going to need to use that our consumption on both goods x and y cannot exceed our income. Okay, so with that out of the way, then what I'm going to do is I want to solve for x and y by themselves. So what I'm going to start by doing is I'm just going to try to get y by itself. And so what I'm going to do is I'm going to take this expression right here, and I'm just going to bring it down here. Okay. So what I'll get is alpha times beta times y over x equals px over py. And recall, I just want to get y by itself. So what am I going to do? I'm going to multiply both sides by beta over alpha. And I'm just going to multiply on both sides by x. So x is canceled here. And what am I left with? Just to recap, y is now going to be equal to beta over alpha px over py times x. Oops, my times looks like a double x. So let's just make the times a dot there. Okay. So times is just a dot. Okay. So now what I can do is I can recall that I have my budget constraint here. Okay, and what I'm going to do now is I just want to solve for x by itself. In essence, what having this MRS equals px over py plus the budget constraint, what does that give us? Well, recall we want to solve for values of optimal x and optimal y that my consumer would consume. And so these are two equations that I can use to solve for these two unknowns. And so what I'm going to do is, now that I've simplified this, I'm just going to plug it into my second equation, and that should be very familiar given the steps to solve a system of equations. So what I'm going to do is I'm just going to plug in for y there with this expression right here. I'm just going to plug it in right there. And so what will that give me? It'll give me beta over alpha px over py times x. Okay. Now what I'm going to do, just to simplify things down just a little bit, is I'm just going to pull x out of both parts of this expression. and so what I'll get is x px plus and so notice that if you bring this py inside this expression, these py's cancel, and so what you'll be left with is beta px plus px beta over alpha times px. Okay, so just to simplify that down, just really quickly, I'll pull out the px and be left with 1 plus beta over alpha on the other side. Okay, so now what I'm going to do is recall that this is just all equal to income. So what I'm going to do is I'm just going to divide on both sides by px, 1 over alpha plus beta. And so what does that give me? That gives me x is equal to I over px. And then I notice that I have 1 plus beta over alpha in the denominator. But what I can do to simplify that, oops, too far, is notice that 1 plus beta over alpha is equivalent to saying alpha plus alpha over beta. Recall this is just 1, so I'm just figuring out another way to write this as form of 1. Alpha plus beta over alpha. Okay, and so now if I go back up here, recall that that was in the denominator, and so I'll just get alpha plus beta over alpha. Or I could flip that up into the denominator and just get I over px times alpha over alpha plus beta is equal to x star. Okay. And so you can notice that alpha, okay, so a couple things to note. Note that alpha over alpha plus beta is less than 1. Or, yeah. So notice that if I just take this expression here, and I bring this down, notice that this is the same if I just multiply on both sides by px. This is the same thing as writing px times x star equals I times alpha over alpha plus beta. Okay? So if alpha over alpha plus beta is less than 1, then this is saying that if I notice that the left-hand side is just expenditures on x, and this is my income, then this term here is the share of income spent on x. Okay? But likewise, we have to spend all of our income on either x or y. So therefore, it must be that I spend the remaining share, that's beta over alpha plus beta, on expenditures on y. And so without even needing to do the math, although I could, notice that I could have here instead. Now that I know what x is, I can just I could have solved for x up here, or I could go in back here and plug in for x here, and so then I get y. But a simple way is just to notice that expenditures on x and y must add up to my total income, and the thing multiplying income is just a share. So the remainder must be spent on good y. Share of income spent on y. Okay? Notice that if alpha plus beta is equal to 1, then this is even easier. It just becomes that we spend now. So if we assume that alpha plus beta is equal to 1, then we now spend beta times I. So beta is now the share of income spent on y, and if alpha plus beta is equal to 1 there, then this just becomes alpha times 1, and now alpha is simply the share of income spent on X. And so going back to the slides, the slides say the same thing, that we use our utility maximization rule, or MRS equals the slope of the budget constraint, to solve for y as a function of x. We plug that in the budget constraint. That gives us the optimal x. Then we can just plug this x back into here to solve for the optimal y. And then note that when we have alpha plus beta equals 1, the general solutions simplify and become like follows. However, the simplest way to remember them is just to rewrite the above as expenditures. That is, the amount that I spend on X is just the amount I buy of X times its price, and the amount I spend on Y is just the amount I buy of Y times its price. And so the useful interpretation of the coefficients alpha and beta is that when you look at a utility function, you can immediately go, oh, I know this consumer is going to spend alpha percent of their income on good X and beta percent of their income on good Y. And so that's exactly what a Cobb Douglas utility function does. And so it's important to remember that useful interpretation because it will allow you to skip doing that math in the future. And so in exercise 4, let's just go back to our example in utility maximization, where utility of apples and oranges was equal to apples to 2/3 and oranges to the 1/3. And we're just going to assume that income and prices were the same. Well, note that here we quickly can know that we're going to spend 2/3 of our income on apples and 1/3 of our income on oranges. And so just note that if we rewrite that, that means that apples is going to be equal to 2/3 I over PA. And if we just plug in for income and the price of apples, that gives us 60 over 4. And so canceling everything out, we get that consumption of apples is equal to 10. Likewise, we're going to spend 1/3 of our income on oranges. So if we divide both sides by PO, we get that oranges is equal to 1/3 of I over PO. We can plug in for the price of oranges, which is just 2, and our income as before. And so we get oranges here is equal to 10. And so remembering the intuition of, or the general solution to the Cobb Douglas utility function can save you a lot of time compared to what we did earlier in this section. So thanks so much, and I'll see you next time.